We are going to study about locus, problems on locus. Already I have studied about what do you mean by locus in the session 18. So we are going to see some problems on locus. For that we are going to see three problems here. First problem deals with modulus, and second problem it deals with real part, imaginary part, like the type of problems, and the third problem it deals with argument. So here we are coming across of all the types of things in the complex number, that is regarding modulus, then real part and imaginary part, and then about argument, that is angle. So now let's see the first problem, that is locus of modulus of z minus 4i by z plus 4i is equal to 1. Here we have to find what is the locus. That is a variable point or a point is moving in such a way modulus of z minus 4i by z plus 4i is equal to 1. Here this z is that point, that is moving point. So some point is moving such that this value becomes 1. If it moves like this, then what will be the structure of that movement, or what will be the path, that we are going to discuss. For that, let us do one thing. Since this is a variable, let us treat this as x plus iy. Now just substitute x plus iy in the given problem. If already you know modulus of z1 by z2, modulus of z1 by z2 can be written as modulus of z1 by modulus of z2. So if the division comes this side, it will become as multiplication, and our answer is modulus of z minus 4i is equal to z plus 4i. Right. Now let us substitute that z value. That is, z is nothing but x plus iy. Right. Now let us collect real parts together and imaginary parts together. Here x is our real part, but imaginary parts, this iy and minus 4i. Here this iy and plus 4i are imaginary parts. Let us collect real parts together and imaginary parts together. So our answer will be, that is x plus I into y minus 4. Here x plus I into y plus 4. As we know, modulus means it is nothing but square root of real part square plus imaginary part square. So if you do it, we'll get the answer as x square plus y minus 4 the whole square inside the square root, that is also equal to square root of x square plus y plus 4 the whole square. First let's remove this square root by taking square. So squaring both sides, we'll get the answer as x square plus y minus 4 the whole square is equal to x square plus y plus 4 the whole square. Now let us simplify this using a minus b the whole square formula and a plus b the whole square formula. Our answer will be x square, this is x square, for a minus b the whole square, a square minus 2ab plus b square, that is a square minus 2, here this is your a and this is your b, so minus 2ab plus b square. The same way to the right hand side, that is x square. Here we can apply the formula a plus b the whole square. A is your y and b is your 4. So a square plus 2ab plus b square. Right. Now if we simplify this, we'll get the answer as minus 8y is equal to plus 8y, because x square and x square will cancel one another, and y square will cancel one another. 4 square and 4 square will cancel one another. The remaining is minus 8y is equal to 8y. If you simplify this, our answer will be 16y. If minus 8y comes, this will become as plus 8y, that is 16y. So that is nothing but y is equal to 0, that is x-axis or real axis, because you know y is equal to 0 means you know that is x-axis, in complex number, that x-axis is represented by real axis. So the problem given to us says if a point moves with this condition, it will be, that point will be moving on the real axis, or the path that will be traced, that is traced by that moving point, will be surely the x-axis, that is y is equal to 0, it says. So let us verify this with a diagram, right? Is it so or not? Here if you see, this is the point first here, is that is z minus 4i. Minus 4i is a constant, it will not change, so this is your minus 4i. Since it is I, we are taking on the imaginary axis. Here on the right side we have plus 4i. This is also constant, it is not going to change, so that should be here. That is, since it is plus 4i, it is taken in the imaginary axis with positive value of 4. So this is minus 4i and this is plus 4i. These 2 points will not change. Now the condition says a point z, this is that point, variable point z, it is moving in such a way, distance from this point to that moving point, distance from this point to this moving point should be equal to distance from this point to this point. So simply a point is moving in such a way, distance from this particular point to that moving point should be equal to distance from this minus 4i, this particular point, to that moving point. Both should be equal to one another, it states. So if you see, if you take this length, here is your z, so this distance is equal to this distance. If the point comes to this place, this is modulus of z plus 4i, and this is modulus of z minus 4i. So whatever it may be, distance between these two and distance between these two are equal to one another. So if a point moves like this, surely wherever it go in this line, always distance from this point, that is moving point, to this plus 4i, and distance between this point to minus 4i will not change. So we have received the same answer as x-axis, what we have done with equations. We have received the same answer graphically, right? So the locus of modulus of z minus 4i by z plus 4i is equal to 1 is nothing but y is equal to 0, that is real axis. Now let us see another one problem. Here a point is moving such that its imaginary value should be always equal to 0. That is, a point is moving, z is moving such that this part's imaginary part should be equal to 0, and the question is find the locus. Right. How to do it? The same way, it's very simple. We are going to consider that z as x plus iy, and we are going to simplify this part, and we can get its imaginary part. It is very simple. So the given is imaginary part of 2z plus 1 by iz plus 1 should be equal to 0. Let us consider z as x plus iy. If z is x plus iy, instead of z we have written x plus iy, and also for this z x plus iy. If we simplify this, we'll get the answer is, that is 2 into x, 2x, 2 into iy, 2iy plus 1 divided by ix, I into I square, that is plus I square into y. I square value is minus 1, so this is minus y plus 1. Right, now let us collect real parts together and imaginary parts together for the numerator as well as for the denominator. So our answer will be 2x plus 1 plus 2iy For the denominator, that is 1 minus y is our real part plus I into x, that is our imaginary part. As you know very well, we should not keep imaginary part in the denominator. So let us take conjugate to this expression and let us multiply the numerator as well as the denominator by that same complex conjugate. So your result will be like this, that is 2x plus 1 plus 2iy divided by 1 minus y plus ix into same. For this we are taking conjugate, that is 1 minus y minus ix. With that same, we are multiplying the numerator as well as the denominator, so the value will not change. Right, now let us multiply these two. That is, your answer will be, that is 2x plus 1 into 1 minus y, then plus into minus, minus 2x plus 1 into ix, plus into plus plus, that is 2iy into 1 minus y, plus into minus, minus 2i into I, 2i square x into y, xy. For the denominator, there is no need of multiplying like this because this is complex, this is its conjugate. To multiply, the simple way is real part square plus imaginary part square. Here the real part is 1 minus y, here the imaginary part is x, so x square. So we have simplified this. Let us try to simplify this again. Right, is very well, this I square value is minus 1, so minus 2xy becomes plus 2xy. Right, now this is real part, this is real, these two are imaginary part. Denominator will be common for both. So if you try to find imaginary part alone, because we need only the imaginary part, if we take imaginary part alone, that will be minus x into 2x plus 1 plus 2y into 1 minus y. So this is our imaginary part. Whenever we consider the imaginary part, we should not take I. Just we have to remove I from that and we have to collect the terms. So our imaginary part will be minus x into 2x plus 1 plus 2y into 1 minus y. Denominator will be as it is. It is given that imaginary part should be equal to 0, so that is considered as 0. So up to this we have simplified the problem. Now let us try to simplify it again further. That is, the denominator value, when it comes to the 0, it becomes 0 into anything becomes 0. This is your answer. Now let's change the sign on both sides. That is 2x square plus x minus 2y plus 2y square is equal to 0. Let us collect 2x square and 2y square together and x term and y term after that. So your answer will be 2x square plus 2y square plus x minus 2y square is equal to 0. If you see this, you can come to the conclusion it is just like a circle. Because general equation of a circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Right, there will be no xy term, and the coefficient of x square and the coefficient of y square will be equal to one another in the circle. So this is our general equation. Sometimes if you want, we can write ax square plus ay square here, but this is enough. Right, so let us try to bring this equation in this format. Then it will be easy for us to find center and radius. Here the coefficient of x square and the coefficient of y square are equal to one another, and that is equal to 1. So let us divide the whole equation by 2. Right, that is x square plus y square plus half x minus 2y by 2, that is minus y equal to 0. Right, now if you see, it is very clear, it is in this format. So this is a circle. So the path traced by that variable point or the moving point is nothing but a circle of this equation. So let us try to find center as well as radius. Center is minus g comma minus f, and radius is root of g square plus f square minus c. So first of all, it is crystal clear it is a circle. It is in the form, the equation is in the form x square plus y square. This is 2gx and this is 2fy, and there is no constant term, so c should be considered as 0. So 2g is equal to this 2gx, so 2g is equal to half. This is 2fy part, so our 2f is nothing but minus 1 and the constant is 0. From here we can find g value as well as f value. So g will be equal to 1 by 4 and f will be equal to minus 1 by 2, and c, the constant, is 0. Let's try to find its center. Center is minus z comma minus f. So this is nothing but minus 1 by 4 comma 1 by 2. This is the center of the circle. And let's try to find the radius also. Radius value is root of z square plus f square minus c. It's very simple. Instead of g, we have to write 1 by 4 the whole square. For f, we have to write minus 1 by 2 the whole square, and constant is 0. If you simplify it, that is 1 by 16 plus 1 by 4. If you take LCM, your answer will be 5 by 16, root of 5 by 16. If we take square root, that is, this is root 5, and if we take square root for 16, the answer will be 4. So the path traced by that moving point is nothing but it is a circle keeping minus 1 by 4 comma 1 by 2 as center with radius root 5 by 4. It works. So if you trace it, it will be like this. So this is the real path traced by that moving point. With that condition, when the point moves, it traces like this, it goes like this, so it forms a circle, right? So now we know how to find the locus of a moving point with real part or imaginary part, like that conditions. Again, let's go to the one more problem that is regarding with argument, that is angle topics. So this is also very simple. In the same way we have to do, first of all, argument of a complex number is nothing but tan inverse of b by a. If a complex number is z is equal to a plus ib, then its argument is nothing but tan inverse of b by a. What do you mean by argument? It is nothing but angle made by this complex number with real axis. That is called by the name argument of z. So if you want to calculate this argument value, surely we need tan inverse of b by a. Here a is our real part, b is our imaginary part. So in this problem, it is must for us to find real part as well as imaginary part. So let us try to do in the same way. As you know, this z is a moving point. It is a variable point. Let us consider z is equal to x plus iy, right? So first let's try to simplify only this part, that is z minus 1 by z plus 1. For z we have written x plus iy. For this z also the same, x plus iy minus 1, and for this plus 1. Again the same way, let us bring real parts together and imaginary parts together. If you simplify this, you'll get x minus 1 real part plus I into y imaginary part. The denominator, the real part, is x plus 1 plus iy, that is the imaginary part. As you know very well, we should not keep I in the denominator, so let us multiply the numerator and denominator with the conjugate. The conjugate of x plus 1 plus iy is x plus 1 minus iy. Using that complex conjugate, we have multiplied the numerator as well as the denominator. Let us try to simplify this. Right. If we simplify, that is x minus 1 into x plus 1, then plus into minus x minus 1 into y. Here plus into plus iy into x plus 1, plus into minus I into I square, y into y square. Denominator, this is complex, this is conjugate, so there is no need of multiplying. We have the formula real part square plus imaginary part square. Here the imaginary part is y. Right. Now again let us try to simplify this because I square value is minus 1. So if you simplify this, your answer will be like this. That is a plus b into a minus b. Formula is a square minus b square. That is x square minus 1 square. This is one real part. These two are imaginary part because I is here. But here I square is here. I square value is minus 1. So minus into minus becomes plus. So it is simply y square. So it is our real part. So if you simplify this, let us collect with the real part plus y square. And in the imaginary part side, this is plus iy into x plus 1. This is minus iy into x minus 1. Let us take plus I commonly outside. Then this is xy, y into 1 plus y. Here we have taken only, commonly we have taken only I. So minus is here. So minus y into x minus xy, minus into minus plus y into 1 y. Right. So real parts are collected together and imaginary parts are collected together. Denominator is common for the both. So the real part is x square plus y square minus 1 by this, and real part is, imaginary part is minus xy and plus xy will get cancelled. So 2y by this. So our real part is x square minus 1 plus y square divided by x plus 1 the whole square plus y square, and our imaginary part is 2y by x plus 1 the whole square plus y square. Right. Now let us go to the condition that argument of that complex number should be equal to pi by 2. Right. That is argument of z minus 1 by z plus 1 is equal to pi by 2. We know the formula for this argument, that is tan inverse of b by a. B is our imaginary part, this one. A is our real part, this one. So let us apply this formula, that is tan inverse of b by a is equal to pi by 2. Instead of b, let us replace b with this 2y by x plus 1 the whole square plus y square. For a, let us replace that a by x square minus 1 plus y square by x plus 1 the whole square plus y square. These two terms are common. So if you simplify, these two will be cancelling one another. So if you simplify, your answer will be tan inverse of 2y divided by x square minus 1 plus y square equal to pi by 2. When the tan inverse comes this side, it will become tan pi by 2. So 2y by x square minus 1 plus y square is equal to tan pi by 2. You know, tan 90 value is infinity, that is nothing but 1 by 0. So 2y divided by x square minus 1 plus y square is equal to 1 by 0. So if you cross multiply, that is 0 into anything is 0, and if it comes this, it will become multiplication, that is 1 into this will be equal to the same, that is x square minus 1 plus y square. So 0 is equal to x square minus 1 plus y square is equal to 0. If we bring this minus 1 this side, it will become plus 1, that is x square plus y square is equal to 1. Right. This is also a circle of special type, because you just, according to the condition, if you see coefficient of x square and coefficient of y square are equal to one another, and there is no xy term, so surely it will be a circle. There is no x term, there is no y term, that is not a matter. Coefficient of x square and coefficient of y square should be equal to one another, and there should not be any xy term. Then surely that equation will be a circle. This is a special type of circle. Its radius is 1 and its center is 0. So if a point moves with that condition of argument of z minus 1 by z plus 1 is equal to pi by 2, then the path traced by that point will be a circle of radius 1 with center origin. I hope so you would have understood all these things. It's very simple. Here we have discussed about 3 things. All the things are dealing with modulus, locus. First with modulus. Second, it deals with real part or imaginary part. And third, it deals with argument value. So all the three problems dealt with different type of things. So I hope you would have understood all these things. So practice from your textbook examples as well as exercises to have more knowledge in this part. Thank you.